we're going to be talking about processing composite materials. So there's some materials that no matter how much you try, low pressure piercing, whatever technique, you can't pierce it without delamination, or maybe you can get it where 99 out of 100 times it'll work, that 100th time delaminate and just ruin the entire piece of material, which might be worth thousands of dollars. So in that case, drilling of carbon fiber is a good option, and we'll look at that today, some of the things that go into that as far as drill type and design of machine.
Alright, so today I've got a couple special guests with us. Got Alan Bernard, who's in charge of our technical support division. Alan, give us a wave. Alan's been with WARDJet now for 17 years, so he's responsible for supporting all the machines that are out in the field. So he has a very unique perspective on real-world applications. And then we've got Ben Adams. He's also been with WARDJet for 17 years, since machine number 2 it was.
Number 1. I was there for number 1.
Oh, great. He's manager of engineering, so gets to oversee all the electrical, mechanical, software engineers here at WARDJet. So just want to have you gentlemen talk a little bit about dealing with composites, drilling specifically. It's an application that we come across frequently, and certainly it's got some unique applications, some unique things that we have to consider. So I guess starting with you, Alan, you hear that there's a machine that's going out in the field and it's going to be drilling composites. What sort of things are on the front of your mind when you're knowing that you're going to have to support this machine?
Carbon fiber has got unique characteristics. One, there are, you've got the pleating that's going on inside of it. Second of all, it will delaminate easier, and it's very abrasive. So in other words, it basically is not very conducive to drilling. You're not going to get many holes out of one insert, so that you can get small chips and get the chips out. And pick, in some cases we pick to get through the material so that we minimize or have a zero delamination on the exit of the drill. You don't need coolant on those. You could, if you had the capability, you could put air through the drill just to blow the carbon fiber out. That's actually the way to go, and because the cutting forces when you're driving down, the carbon fiber will push back at the drill, and you're gonna have some. If you don't get those chips out, or it will push back, and you're gonna get the drill moving on you as well.
Anytime we do a drilling application, we pick a Z carriage that is suitably stiff, because we'll now see some forces working back on that carriage, back on our gantry, that we don't see during waterjet cutting. So it's important that we choose a heavier duty carriage that's got usually 2 rails separated by a certain distance, multiple bearing packs that can take that load, and avoid any twisting or torquing when you do a drill. Sometimes we'll put a drill offset, not centered on the carriage. Usually that's where the waterjet head goes. And so if the drill is 6 inches over to the right, then it's all the more important that you can take that twisting and side loading on a carriage. So we'll pick the appropriate parts for that during the time, or if customers looking at maybe adding that capability down the road, we may choose that kind of carriage up front so that they're ready to go if in the future they want to get into composites and they want to add a drilling capability after the fact.
Well, gentlemen, appreciate your time. I'm going to go out now and do some actual cutting and take a look at the machine we've got on the floor. So appreciate it, and have a great day.
Thanks, Jim.
Thanks.
Yeah, bye.
In this video here we're cutting 1/4-inch carbon fiber. The drill option is available on all of our abrasive machines except for the A series that we'll see here in a bit. Here we'll see the drill first go around and pre-drill all the pierce holes. Then the cutting head will go back and pierce through those holes. Effectively, we're piercing off the edge. Drilling is a very reliable way to create starter holes in composite materials. There's very little that can go wrong. You'll note that we are drilling on top of plywood. You'll want to have some sort of sacrificial material under the material you're drilling so that the drill doesn't end up going into a grate at some point. Another interesting application for pre-drilling is laminated shims. Companies will stack 50 or more layers of material, thousandths to 5,000ths of an inch thick, squeeze them together in a fixture, and then pre-drill the pierce holes and cut. The finished product looks like a solid piece of material, but then you peel off the shims to the thickness that you need.